Good morning, everyone. Today I'd like to cover control structures. These are structures that allow execution of expressions within a program in not necessarily sequential order. And after having covered loops and conditional statements, I'd like to maybe briefly touch up on how you would write functions in Python. And at that point, I want to conclude the Python segment of this course, and I want to return back to the fundamentals of biology. And hopefully in 2 or 3 sessions, we'll be done with that, and from there we can get really to basics of bioinformatics. So let me start by creating a project in PyCharm. So in PyCharm, I'm going to call this one to be loops. When you create a project in Python, it automatically names the default Python script to be main. You can just go ahead and delete all this, start writing your program right here. I just would like my program to convey the concepts that I am going to cover. So I want my program to be called not main.py, I want it to be called loops.py. So I'm going to delete this one. I'm going to create a new Python file called loops. And that will create the loops.py here. The only problem is that if I want to write a program and execute it, you will get an error at this point saying main.py is not defined. That's because the project still points to the program main.py as to be the main point of execution. So I want to change that loops.py, edit configuration, and here instead of main.py you can say loops.py. And from here on, when you execute, everything is going to be correct. Now, just the basic coverage. So a typical program, it executes commands sequentially, one after the other one. So if I had 4 or 5 instances of a print statement, the first one would be printed, followed by the second one, followed by the third one, and so on and so forth. In vast majority of programs that we write, we don't want to just put a sequence of commands to be executed without any conditional checks. So every so often we want to stop and check a particular condition and see based on that condition should I execute A or B. So your program can branch and execute different paths and different set of expressions and commands. In some other instances, you want to execute the same thing numerous times based on some internal conditions. So those are the control statements, which I'm going to start by covering the for loop. And after the for loop, we're going to go into maybe while and then if statements. So the very first thing that I want to do is that I can say the syntax of for loop is for, the reserved word for. You give it the loop counter. So for example, I'm going to say, I don't know, say I, a number. And then you need I to repeat over a range of numbers or conditions. So in this case, I'm going to say in range 0 to 5. So I is going to loop over all the numbers, integers, starting at 0, ending with 5, not including 5. And it's going to do something with those. Excuse me. So for loop, in that first statement needs to be terminated with a colon, and that specifies the end of your for loop. And from here, everything is indented as part of body of that loop, and I can say print, for example, I is. So if I was to execute this now, you would see that I will be going from 0 to 5, not including 5. So range function, you can look at it. It has a variety of features, including you can say every 2 steps. And now it will start from 0 to 5, incrementing every 2 points. Now, so this is only if we are going to repeat the inside of a loop based on numbers. In bioinformatics, oftentimes it may be numbers, oftentimes it's based on length of a sequence. So I'm going to actually introduce a sequence at some point soon. But before that, what I want to do is to cover the while loop. I personally would rather see a program written with for loops instead of while loops. But in some instances, usually in other programming language, the two are kind of interconvertible. But in Python, it's more the case that given the basics of Python, you may not be able to write some loop as a for loop, and it has to be a while loop. And I'll show you an example. So if you wanted to write the exact same for loop as a while loop, you need to start with the index of the loop, which is here I. I'm going to set it to be at the starting condition. So I starts with 0. Then you say while, and you specify the condition where the inside of the loop is going to be executed. Well, while I is less than 5, followed by semicolon. I personally like to have these individual conditions to be within parentheses, but for now I'm going to ignore those until they're needed. So while, again, you start with the index of the loop, you set it at the initial condition, the reserved word while, you specify the condition under which the while loop should be executed, terminated with the colon, and then the body of the loop. Now, inside the body of the loop, the loop index I needs to be incremented as desired. So for example here, I need to say I equals to I plus 1. So this loop will enter, I is equal to 0, print statement will be executed, I will be incremented by 1, assigned to I, so I basically will be modified by 1. And then you will return to the beginning of the while loop. While loop will examine whether I is less than 5. If so, then it's going to execute. So this will be executed until I becomes 5, where while loop will test the termination condition of I less than 5 is not true is false, therefore it will execute the while statement. So let me just execute this and see. So the for loop goes 0 to 4 because it's incrementing by 2, and while loop is incrementing by 1, and it will basically go 0 through 4, all the way inclusive, and then it will terminate. If you wanted to do the same thing, if you wanted to do the same thing of increment of by 2, then basically here you would increment things by 2, and then both for loop and while loop will be identical. The only place, let me first take a look to see, so let me just complete this, actually. So the only place is, let's say I want to repeat a for loop, so let me, where I don't want I to index over whole numbers going 0 through 5, I want I to go from 0 to 1, in increments of 0.1. So desirably what I would want So I want I to be 0, 0 0.1, 0 0.2, 0 0.3, all the way to 0 0.9, and at 1.0 then exit. Unfortunately, as Python as it comes, this particular thing does not work, and it creates an error basically saying that range function needs to have whole integers. And this is the only time that you may want to resort to while loop instead of a for loop. So in here, nothing stops you from performing the following. And this will basically do what it is that you want it to do. Yeah, I keep falling for this. This is the indentation that if things are off by one space, it's going to cause issues. There are a number of things to notice. This particular approach is not necessarily the best approach. It could be the source of many different bugs, including, as you can see here, everything should be cleanly 0, 0 0.1, 0 0.2, 0 0.3. But you see, for example, in the case of 0 0.3, there is actually accumulated numerical error. And you can see here, instead of being 0 0.8 exactly, it's 0 0.799, 0 0.899, 0 0.999. And you can see my intention was for this program to go all the way to 0 0.9. And in fact, it kind of almost went all the way to 1. So for those of you who are more experienced programmers, you will know what's the flaw here. And in general, if you were to do this, the better thing to do is a little bit more complicated. Just write a for loop that will be executed 9 times or 10 times and divide everything by 0 0.1 to create the numbers that you want inside the loop. But if you need it, there's for loop, there's while loop, there are other forms of loop. But for now, I'm just going to really rely on these two unless the need comes for other control structures, and I will introduce it. For now, most of what I'm going to do, my personal preference is for loop is a lot cleaner, so I'm going to try to do something with for loops. Now, in some instances of program, you want to check a particular thing, and you want to see whether a number is positive, do something. If a number is negative, do something else. And basically look at conditionals. That conditional statement is if. And what I want to do, give you some examples of if, some simplistic examples, and from there build it towards one of the first examples of something that we normally do in bioinformatics analyses. Now, I'm writing that program myself. Of course, it is available as part of packages in numerous different packages, actually. But for now, let's just make sure that we know enough to be able to do this. So I am going to say my character. I'm going to get it from screen. We haven't covered this yet, but we will soon. I'm going to get a character from input, from command line, from keyboard, prompting the user. And I want to check to see whether that's a valid A, T, C, or G. If not, then I'm going to basically issue a command prompt. I'm going to issue a statement saying that whether that character was a valid character or not a valid character. So the first thing that I want to do here is, so the character is received. If you recall, input returns everything as literally string characters, so I'm good to go with that one. I can say if my char, okay, so I need to explain a few things. Let me first write it and then. Let's just do this. So your if statement, you're going to have an if. It's just almost exactly like all other programming languages with slight subtle differences. So if, and then you're going to have conditionals. You can have a single conditional that you're checking. So in here, you're going to say whether the content of my care, and I put equal, and in comparison to a single equal, this is a logical comparison. So this one compares the contents of my care to the string little c. If they are the same thing, then the program execution is going to enter the inside of the if loop, and it's going to execute this statement. If they are not the same thing, then the content of the if loop are going to be skipped, and program execution is going to resume from what comes after the if statement. So if there was something here, that would proceed. Now, to make a distinction again, there's a equal sign, which means they contain the same value. It examines to see if they're the same value. Whereas a single equal, such as this one, it assigns the value. It's called assignment operator, and it assigns the value of the right-hand side to the entity on the left-hand side of the expression. So this is called assignment operator. This is equivalence. This is comparison operator, and the two are completely different things. In different programming languages, it is possible for you to do this. Python is smart enough that this allows this. You can call it smart enough. Some advanced programmers want to take advantage of this, and they can't, so they get annoyed. But for most beginner programmers, this is a good safety check. So if I was to run this program, at this point of execution, the program execution is halted. A prompt is generated. It says, please enter a valid genomic character. I'm going to say C, and it's going to come back and say, you entered a valid character. So it performs a comparison. It comes back and says, yes, you entered the valid character, which was C. If I run it and give it a different character, give it, for example, I don't know, A, nothing happens because this statement is excluded and execution follows after the body of the if loop, which there is nothing there, so the program terminates. You could then augment this by a sequence of what is called else statements or if-else statements or else-if statements. Let me give you another example of this, which with numerical values. And let me just, for simplicity's sake, I'm going to comment all of this out. So these are all commented. So let's, I'm going to write a program now, a segment of code that will prompt the user to enter a number, and it will check to see whether the number is positive or negative. So the first thing that I want to say, my number, now remember Python's input command prompts the user, the programmer or the user to enter a number, but whatever is input is going to return it as a string. In order to convert that to an integer number, which I'm going to work with it, I need to execute or cast it, convert it to an integer. From this point, I'm going to perform, if my number is less than 0, then I'm going to say however, if that is not the case, else So the execution goes, if the number is entered, number is converted to an integer, assigned to my number, then when you enter the body of the if statement, the first thing that happens, if my number is going to be compared to 0, if it is less than 0, then this statement will be executed, which basically, indicates that the number was negative. Otherwise, else, this statement is going to be executed. So in this particular if statement, the way that it is written, the moment you include else, always one thing or the other thing is going to be printed, executed. In this particular case, I have only a single print statement, but each one of these blocks of code could be large numbers of codes and therefore do meaningful things. So if I was to execute this, I'm going to give it 10, and it's going to say the number is positive. If I run it again and say -10, then it's going to say the number was negative. Now, in some instances, my if-else conditions may not be just if followed by else. It may be numerous else-ifs that I want to consider. So, for example, in this particular case, a number can be negative, positive, or just 0. So I want to be able to discriminate whether a number was 0, whether a number was negative, or whether a number was positive. So I can do the following. It's called else if, and then I can give it a condition. I can say if my number is greater than 0, then I basically say it's positive, and after this point, if a number is negative, this will be executed. Otherwise, if the number is not negative, then you will jump right to the next else if. This conditional will be evaluated. If it is true, this statement will be executed, and then the program execution jumps to the end of the body of if block, so after the else. If this is false, then the else statement is going to be executed and it's going to drop out. In which case I want to say so I can give it 10, number is positive, -10, the number is negative, and 0, and your number is 0. The number of else-if statements you can have within the body of if statement is unlimited. You can put as many as you want. There are, however, good programming exercises that usually you don't want to have too many of them. You don't want to make these expressions of logical comparisons to be too large. The other things that one would want to know is the way that you can perform logical combination of these comparisons, and I'm going to just kind of briefly show you the next version of this program, and hopefully in that context demonstrate both of them. So let me also convert all of these to comment. So let's go with I'm going to just copy paste it here so I don't have to waste your time looking at what I'm doing. So let's go through over this little segment of code. My character is going to be something obtained from the user by prompting the user. Then what I want to do, I want to check to see whether that character is a valid genomic character, whether it's an A, T, C, or G. If it is any of those, then I want to echo information about that to the user and let them know that the character they entered is a valid character. Otherwise, the characters are going to be further examined. Sometimes in bioinformatics you'll see in sequence representation. If something is unsure, if a character is uncertain to be A or T, it may become an X. If it is not clear whether, so under some ambiguous conditions, a reasonable or valid genomic character in sequences may be X or N. So this particular program checks to see whether you have an exact character ATCG. If it is, you'll say valid. Otherwise, it say is an acceptable but ambiguous character. Or otherwise, it will just simply say it's not a valid character. So this one serves to illustrate a little bit more complex comparison operators here. So I have my logical expression in here as part of my evaluation for if statement. My character can be an A if it is the same thing as A, and they are combined together with logical operators either or, and. So if my character is an A, or my character is a T, or my character is a C, or my character is a G, then I print this statement. Otherwise, else, if my character is an X or an N, I'm going to print this character, and otherwise I'm just going to say that it's just not a valid character. So if you execute this, I can give it A, for example. It will say it was a valid character. I can execute an X. It will say it was possibly a valid character. Or otherwise, it's just going to basically say that it was not a valid character. So if I give it B, it will say it's not a valid character. The issue here is that sometimes when you get information, you want it to be case insensitive. So whether I put A or I put A, they should both be the same thing. Whereas in here, in this segment of code that I have, whether if you have a capitalized A, it's accepted. If it is a lowercase a, it's not accepted. So you may want, in these circumstances, to make sure that everything is converted to uppercase. Now, I think I covered in some of the basic the attributes and methods that are included in strings. There's an upper, there's a count, so there's a lot you can do with strings that you can just convert it to upper, everything will go to upper. So those are all good things to do, but what I want to do, I want to get into functions. Actually, so the way that I have, what I have for function is slightly different. Let me actually, so before I go there, let me discuss something else. I guess I would like to connect for loop to strings. It may be obvious, but I like to cover that just to be on the safe side. So we have for loop, we have covered strings. Let me combine the two together. So let's say, for example, I have a string. So here's a string that I have, and let me just not worry about X and N here. Let me just leave it like this. I can do the following, and that will print my sequence. Let's say now I want to literally print the sequence one character at a time, and you will see why I am doing this. So what I can do, I can say my character in, and at this point you only have to say this. And what basically is my sequence is going to be considered an array of characters, and you can walk through every one of the characters in your string. So these are the reasons why Python are so much more convenient to program in compared to, let's say, C++ or Java. So you can basically throw something like this and it just works. Now I can say print my char. if I was to run this program, you will see that all the characters of my seek, which was A, T, T, they are being printed, so my for loop is working fine. I'm getting A, T, T, little c, and so on and so forth. Except I would like to print them all sequentially next to each other, such that this for loop basically does exactly what this print statement does. So the way you suppress that end of line character that's automatically printed by a default print statement is that you can say end equals nothing. So by default, I don't know if I covered this while I was doing simple I/O, but print statement in Python, by default, it puts a hard carriage return at the end of whatever it is done printing. So at the end of whatever it prints, it just puts return, carriage return line feed, and it goes, the next print statement will be printed onto the next line. To suppress that end of line character, you can basically say end equals nothing. So then to for loop and the entire just printing the entire string produce the same thing. The advantage here is what I can do, I can in here say if my char is equal A, then I can print a capital A. Yeah, I'm a little bit struggling this morning. So then, so this basically provides a mechanism that I can go through a string and make sure, evaluate every one of the characters and make sure that if the character is lower, convert it to upper. Make sure if a character has some anomalous thing appearing with it, then I can correct it. I can count it. I can do a number of things in here. So a lot of them can be done with simple methods that are available to string by performing mySeek.upper, everything will be converted. mySeek.count, you can count the number of occurrences of A, T, C, G. So all of those can be done, except maybe some specific things, as you can see, you will see as the course develops. There are specific times that there are times you want to do specific checks that are just not conveniently part of already existing methods. So therefore, you're forced to resort to writing a for loop to traverse your string and then look at every one of the characters and treat it appropriately. So I don't want to take the time to do this. You could basically do so on and so forth. Now, and at the end of it, you can print the character if it is not A, C, any of the lower cases. I don't want to take the time to do this at this point. So you can basically repeat that two more times, check for A, C, T, or G, and from there just proceed forward. Okay, everyone, I'm going to stop at this point. What I want to do next time is maybe in the next session, I want to quickly introduce functions and basically rewrite all of these in a more cleaner and a better programming way of creating functions that will perform all the conversions of the error checkings and conversion of the characters. So I'm hoping that one is going to be a short one, maybe a 15-20 minute one as well, and from there we can start the next phase of the course. Please remember that our plan is to meet again on Wednesday.